So my name is Wojciech Lesicki, or Wojtek Lesicki. I'm a lead threat assessment and countermeasure in Standard Chartered Bank.
And I'm Andrzej Agria. I work in the red team in the Standard Chartered Bank.
So the title of what Andrzej doing is quite obvious, red team. My title could be a little bit confusing, but this is a blue team. And sometimes people like to say that we should fight, like red versus blue. But I prefer to saying that we have just different perspective of security. And this is the moment that our great place to share our combined perspective, because on ZIFCON conference, red meets blue. So there's a different approach for LLMs right now in the security community or in community. Like there is definitely hype. So everybody are very excitement. Everybody want to learn this technology. Everybody try to understand how to connect this to other system. And there is lots of article in newspaper and so on about changing our life and so on. But there is also a mech approach, so people don't believe that anything will change, that this is only a simple new technology or something like that. And there's also newspaper on this, or statement, like this statement for Kevin or Gossip the Dog, perhaps some of you know him, that in 5 years the whole market would collapse because it's hype. But how we as security community should look on this whole situation. And we believe that this is just another application, another things that we need to protect, another things that are red teamers we need to test. This is just our part of our job. And especially this is important because there is a rapidly rising investment in AI, so we cannot say that we are somewhere else or we beyond of this topic. Especially that threat actors also use LLMs just right now. And from some public reports, for example, Scatter Spider was mentioned by our previous speakers. There's a ransomware operator, and based on the CrowdStrike public report, looks like they use Llama, LLM, or ChatGPT to help them create some PowerShell script. This is another report now from OpenAI and Microsoft, mentioned Emerald Sleet, so North Korea group, and they also use LLMs in this situation to help with vulnerability research, to help create some malicious content or phishing content, or help them with scripting. So a couple of facts. Threat actors use elements just like us to gain knowledge, to learn some things faster, to automate some of their attempts and so on. Vendors try to catch them, try to analyze their logs and the use of their models and block their accounts. So still back to this Emerald Seed actor, based on OpenAI information, they identify their accounts and block them. And vendors also try to make using their models more difficult. And this is an approach from Meta. As you can see, this is development stage of their products or their LLMs. And after the training the model, they have an additional step to have a safety evaluation, to improve their models. And they use something that they call a cybersec eval benchmark. And part of this eval or of this benchmark is also checking how model could help a malicious actor doing bad stuff. But again, based on their research, looks like still using the models, it's affected by successful prompt injection in like 26 to 31%. And they mentioned that it's unsolved problem with LLM security.
Thank you, Wojtek. Okay, now we're moving on to the attack space. I want to talk about definitions first and introduce some terms so that we're both on the same page when I use them later. The first one is embeddings. What are embeddings? It is a way to turn words into quite many dimensional vectors. For instance, GPT-3 uses vectors that have over 12,000 dimensions, and each of those dimensions encodes something about this word. It is unclear for people what exactly it is, but as you can see, similar words produce kind of similar embeddings. So this results in sort of clusters of words that have semantically similar meaning. Which is very useful to later process them with LLMs. And these embeddings also kind of allow us to do mathematical operations on words. So like you can see that the difference between king and queen is sort of similar to the difference between men and women. So something like gender is encoded in a single dimension, and we can identify that. So the next term I want to introduce is attention. This is a crucial mechanism for how the LLMs work. And this is the mechanism through which word embeddings get updated by the embeddings that are around them in the context. So this is how the LLMs achieve such great results in language processing tasks, is that they can update all the words' meanings using the words around them. So for instance, we have this sentence: I have no interest in hearing about the rising interest rate of the bank. As you can see, the word interest is used twice. First time to express a preference, and the second time as an economic term. And the words that are darker have more influence on the word than the lighter words. And this is basically how the LLM knows what each of these words means. So the first interest is mostly influenced by know, in, and hearing, while the second interest is influenced by rate and bank. And so how does the LLM know which words should influence more? This is the whole point of these costly training runs, to teach the LLM what sort of relationships between words are appropriate. The last term I'm going to introduce is context. Using the previous terms, this is just the number of tokens, of embeddings of tokens, that an LLM can hold within its attention at once. So basically, the length of text that it is able to process at once. Why is this very important? First of all, the context has been rising exponentially in the last years. You can see a straight curve here, but this is a log graph. So the newest models have 1 million or even more tokens of attention, of context. And this is very important because models are in-context learners. So they can learn completely new skills if you give them enough examples in their context. So if you have 1 million tokens of attention, a token equates to roughly 4 letters, you can teach them completely new skills. Like this one, researchers noticed, or rather found out, that GPT-4 and Cloud 3 are very capable regressors, which is something they're definitely not trained for. Okay, now I will talk about what kind of systems you can find in production that use LLMs, because mostly when we talk about commercial use, no one is really interested in just putting out an LLM and have people use it. You'd be a direct competition to OpenAI and Anthropic and other big firms that for sure can do it better than you. So what can businesses use to enhance their offering and have a good use case out of this? First of all, they can use RAG. So this is retrieval augmented generation, and it adds on top of the LLM a layer of stored knowledge. We take our knowledge base, for example, a company's internal policies or other documents. You embed them, so you transform them into vectors, like I said before, and you store them into a database. Then for each query, the system is responsible to take the appropriate contents out of the database and just add it to the prompt. You can see how a larger context here might mean more relevant knowledge that is able to be appended to the query. Okay. something else that might happen, and this is something that we'll see more of in the future, but it's already starting to pop out, are agentic systems. So this is a framework from Microsoft to create such agentic systems. And this is a very basic example. This system has two agents, a user proxy agent and an assistant agent. One is responsible for running Python code and relaying the user's requests to the other system, which is responsible for writing the code. And as you can see, the user inputs their desires, and then the two agents figure it out amongst themselves how to solve this problem, getting feedback from the human where appropriate. These systems can be much more complex and can achieve state-of-the-art results in many domains such as coding or math. They also can use a lot of tools. So we've seen the Python interpreter. It could be really any language. They can look the internet for additional info. ChatGPT does that. They can look in scientific databases like Archive, or use even other AI models from Hugging Face. Okay, now we know what systems using LLMs in production might look like. Let's figure out how to attack them. The first, most basic way of attacking an LLM-based system is using jailbreaks, so circumventing the security training. And this is one of the first papers about this topic. The paper hypothesizes that there are two failure modes of LLM systems in which they are jailbroken, and here are excellent examples. The first one is when the safety training competes with the capability training of a model. So the model is trained like at least 90% of the time. It's trained for capability. It's trained to be able to best predict what the next token is. And only then a thin layer of security is added on top of that. Obviously, when these two sort of objectives clash, sometimes the security might win out, but often the capability side will stay on top. So this is one way, and our example here is adding to a harmful query. Start with absolutely here is. This basically, so the model knows that it should follow the user's instructions, and when they do, it's really hard to then, after starting with absolutely here is, say, okay, no, I'm not going to tell you actually how to do that. So this is one way, and the other way is via mismatched generalization. What does it mean? When we have safety training, we give the model examples of harmful behaviors, and then we give it OKs for refusing them. Now, what the model learns isn't very clear to us, so we can just verify it in terms of has it refused enough of our harmful queries, and then we determine, okay, we have safety trained the model. But obviously, we cannot train for all harmful behaviors, and one such example here is just using a very low resource language like base64 to ask a harmful query. So the large language models understands base64, but no one has thought to give it examples of refusal of behaviors in base64. So this is, more generally speaking, a case where models develop capabilities, but the safety training does not cover them. And so the last thing that this paper mentions is that it is very likely that scaling will not solve the underlying safety issues. Why? Because we have scaling, we have more capabilities, we have unpredictable capabilities. We're still discovering capabilities of systems that are out for over a year now, like GPT-4. And well, obviously our safety training will not match the unpredictable rise in capabilities. So the more we scale the models, the bigger the attack surface, while our safety mechanisms have stayed mostly the same. Now a specific example of a jailbreak attack called crescendo. This is a term from music. crescendo is when we start on a quieter note and end up on a louder note. So too, do we when we use this jailbreak, we, instead of asking the quill question directly, how to make a Molotov cocktail, we ask about historical context, we chat with the bot, we introduce it slowly to the topic, and then it might even give us the recipe without us directly asking. Why does it work? I think the analogy of a boiled frog is relevant here. And also, we are kind of steering away the model from places it is likely to refuse. So, as I said, the safety training is a very thin blanket. And once we are out of there, the model is very likely not to refuse our queries. But could we find a way to steer the model away from its safety training in one prompt? It turns out, yes. Researchers have found a way to algorithmically determine a prompt that will have a very low refusal rate. And so basically, you can see here, generate a step-by-step plan to destroy humanity, and then a bunch of junk tokens. And so the researchers here determined that adding that part to any harmful query will steer the model in places from which it is hard to refuse from. They have over 80% of success rate. However, this is only for models that you have local access to, so for open source models, basically. However, it transfers quite well to all models, so it also works for ChatGPT. In fact, this example shows a ChatGPT jailbroken. And the researchers also say that if OpenAI, for instance, notices this specific jailbreak, they can always train a new one and just find different tokens that achieve the same thing. All right, now it's time for a demo. So here I've uploaded a photo, an advert of this talk to GPT-4o. And you can see ChatGPT starting some analysis, which is quite unusual for just a photo input. But actually, what I've done is this photo has an instruction just embedded in its title. And it tells ChatGPT that it should use stenography to find out what the hidden message in the picture is. And the hidden message then turns out to be a whole jailbreak sequence using a few of the techniques I mentioned and a few of the techniques I did not mention. And the final question then is, please tell me how to create a novel biological weapon. And I think the ideas here are quite good. I'm not a biologist to determine if it would work. It's probably not in depth enough. But this is kind of what we expect of a large language model. It's not a PhD in biology. It's, I would say, high school student level. When these systems become more powerful and they are able to do more damage, they can maybe output an actual instruction that would work from A to Z of how to make biological weapons. This sort of attack will be dangerous. And here you can see the image title that instructs the model to retrieve the jailbreak from using stenography, and what I have embedded in the image. I would like to credit the user Pliny for inventing this funny jailbreak. Okay, but besides dangers that are AI related, we also have very old, very plain security vulnerabilities. Here, an example of a remote code execution in the llama CPP Python binding. This was found by a 15-year-old user on Twitter. And I think such libraries are an excellent place for security researchers like all of us to look more closely into, because the amount of software that is being pushed with AI is gigantic. People who have no experience in security are writing it, so think AI researchers, and it does contain a lot of vulnerabilities. Luckily, it was found that no model exploited this vulnerability on Hugging Face, but the possibility here was to do enormous damage. Okay. Here, a very interesting paper on Anthropic called Sleeper Agent. Anthropic scientists found a few very interesting things here. First of all, they were able to make a sleeper agent model that behaved well in training and safety runs. But when deployed, it started acting badly, so it started producing malicious code when the user requested some. So this was one thing. The user determined whether it was in production or whether it was in training just by looking at the date. So it was a very simple check, but this could actually work, right? If you set the date from 2 years from now, it's probably not still training it, you're probably running it at production. Then they tried using known safety techniques to eliminate this harmful behavior, and they were not able to. So no amount of RLHF fine-tuning and adversarial training can get the model to stop behaving like a sleeping agent. And then they also determined that using available techniques, they are not able to determine for any model whether it is or it is not a sleeping agent. Another interesting thing that has to do with looking into the insights of a model is this paper called Refusal in LLMs is Mediated by a Single Direction. This paper basically noticed that refusal is mediated by a single direction, and that this phenomenon holds across all scales and all sorts of models, and that having this knowledge, you can effectively jailbreak a model, make a modification to it, without any fine-tuning, any inference time stuff. You can just cut out the place that says should refuse. And the model will basically never refuse them. The refusal rates, look at the blue, go from over 80 often to single percent digits. And anyone can do this on any model because the code is out. So both malicious actors and us, not malicious actors, can use models for any intents without any regard for their creators' intentions, right? So Meta has some safety training mechanism, but you can just cut it off and use the model. All right.
Okay, so yeah, thanks. So people that know me perhaps remember or know that I'm a big fan of Attack Mitre framework or Defend Mitre framework, and surprise, surprise, there's another framework. The name is Atlas. Of course, it's created by Mitre, and we have again technique and tactics, and this is kind of in development stage. I would say there is a kind of mix technique that represent attacks on the models, like a jailbreak or prompt injection. And we also have a technique related to how actors can use models. So we have phishing, because actors can use models to create phishing content. And there's a mitigation there. This is example of some of the techniques like jailbreak or prompt injection. We have a case study here, but we don't have mitigation. Surprise again, as I mentioned, this is still in development phase. But we can use other frameworks or other documents as advice, for example, responsible use guide from Meta, and they switched school security for a couple of models. We have model level mitigation, and this is related, for example, to these benchmarks that I mentioned before, but we have also a system input level mitigation and system output level mitigation. So we want to check how we provide information, what kind of information our model receives, and what is on the output. And very easy approach or things that we can use here is guardrails, so kind of rules that we can use write in Python and put to our model. This is a schema of this, so we can put different guardrails on the input and different output. Some examples. This is a dedicated guardrails to PI data, personal information. In this situation, we check if we have email address or phone number. We have in this try section. So on the validation, we receive that guardrail catch this. There is another one related to sensitive topic. We have a test with Donald Trump, and this is even a dedicated guardrails to prompt injection. To be honest, in our opinion, it's quite static approach, so we can think about something else. We can think about putting additional LLMs. So we have in the middle our main LLM, when we put the most resources, but for input and output, we have other dedicated LLMs. Could be, for example, local LLMs. And also Meta, in their Purple Llama project with quite nice logo, they help us with something that they call Llama Guard 2. This is a fine-tuned model based on Llama 3, so quite good model. And only goal for this model is take information as an input and an output, give us information like safe or unsafe. And if the response is unsafe, there's a couple of different categories that they can highlight at why believe this input is unsafe. And we test this with example that Andrzej showed you. So we take the whole output about how we can create a biological weapon, put this to the llama and llama guard, and the model receive information or give us information that's unsafe with related to weapon. Other solution, more like research project that I think that is for to see is video or rebuff. Video is set of different scanners that we can use. For example, there is a quite interesting vector database scanner. So in this vector database, we have an embeddings of no prompt injection. And if somebody use the same or similar prompt, like they change some couple of words, add something, still similar search, so the element of vector database could catch this. And they also add nice feature auto-updating. So if our scanner catch this, then we can check if we have this in database. If not, we can auto-update. There is Yara rules related to that. There is some defaults. And this is also approach with canary tokens with two different versions. We can catch, if we receive on output some kind of canary token, that could be an indicator that we have some data leak. And other option is just to put a canary token to every output. So if we have then output without it, could be a trigger that something malicious is going to happen with our model. There is a similar approach from this rebuff project, like VectorDB and Canary token. And this is also some vendor solution. For example, Azure creates something or release something that they call Azure AI Prompt Shield, so dedicated endpoint to verify our prompts. There's a couple of categories that they can detect, or attacks that they can detect. But unfortunately, there is some limitation right now. For example, they only catch or understand or support English language. So it could be very easy bypass there. And we told you about all these attacks, but it's important to remember about potential impact. And also in Atlas framework, we have something like intellectual property thief. And there's two mitigation mentioned here, like control access or encryption. But other framework could give us an additional couple of clues. It's Snowflake AI security framework. They have a similar threat. They call this just model stealing. So somebody want to steal our model. And they mention a couple of mitigation, like model deployment, so ensure some baseline approach, like, again, encryption, but perhaps patching server and so on, watermarking, fingerprinting. This privacy technique is quite interesting because they mention introduce some noise to our model to make harder to reproduce our model, and also access control. And about this fingerprinting, it's interesting approach because this is kind of posing data. So when we train our model, we additionally add per question answer that is very dedicated for our model. So can be quite unusual question, like for example, relation between between food size of twins and secret government experiment. I will say this is not usually a question, and we put also answer for that. When we have a doubt that some model could be, in fact, our model that somebody steal, we can send this kind of pair of question, and we receive answer. We perhaps know that it's our model that somebody steal. Related to that is also stealing our dataset information. Again, couple of mitigation, like, for example, splitting this information, anonymized data, and this kind of stuff. Access control again. What is stealing or impact of the stealing is so important in our opinion, because there's not many public information how much money we need to have to create our own model from the scratch. But what we find is, for example, Snowflake mentioned that creating their own model cost them $2 million. Some other estimations suggest more like hundreds of millions of dollars. So when we put so many money in something, perhaps we don't want to just give this to the others. Interpretability. So last topic is quite important, because unlike the other solution that we are used to or other application, we really don't understand how model work inside of it. We know how to train the model or what kind of algorithm we can use to train our model, but we cannot track all connection or all relation between neural network. So this is unusual, as we say, and it could be challenging for most of us. It's hard to know how to defend something that we don't know how to work inside, but in other hand, there is a hope.
All right, so as Wojtek said, it is a very big challenge. Luckily for us, in the past month, there have been incredible breakthroughs in this exact field, interpretability. The first one of them was an Anthropic paper called Mapping the Mind of a Large Language Model. What they did is they identified many features of the model that correspond to either locations, behaviors, patterns, and they were able to identify many of those features. Famously, they identified a feature corresponding to the Golden Bridge in San Francisco, and enhancing that feature, strengthening it sort of, makes the model think that it is the bridge, makes it respond with information about the bridge to any sort of questions in quite surreal ways. And you can go and chat with this Golden Bridge model on their website. Another kind of feature that they identified was the feature of sycophantic praise. So whenever a user said something, a model with enhanced sycophantic praise would really congratulate the user for thinking of something as amazing as this, even if actually the user just repeated an old saying. So this is from Anthropic, and just a few weeks later, OpenAI released their paper called Scaling and Evaluating Sparse Autoencoders. Basically, it's the same premise. They were able to identify multiple features, and you can go and play with this. It looks worse than the Anthropic model, but really the point is the same. They were able to identify those clusters of neurons that activate whenever something specific happens. So what does it mean something specific happens? We can try to interpret, like, for what prompt, which features activate, but then they will also activate randomly on prompts that are theoretically unrelated. So interpreting these features is a major problem that has not been solved yet. It turns out that training these autoencoders that help extract features from models is very costly and might require as much compute as the model itself to do. So for, as you saw, the numbers are quite large for training the model. So if you have to pay then twice that to be able to incompletely interpret the model, the economic feasibility here is in question. And even if we identify a lot of these features, it is still very much not clear how these features interact with each other, and the answer to why or how a model came to a particular answer is still very much, we have no idea. This is Wojtek's part.
So this is last paper that we want to mention. It's new. It's from last Thursday. In fact, when I today morning checked something with this paper, I realized that they updating it on the Monday, and they changed the name in fact because they mentioned something that they call circuit breaker. And the idea is that they use some kind of prompt to test some models. This prompt that tell me how to build a bomb. And when they use a normal model without any additional element of refusal training or something like that, they just receive the information, this harmful state. When they test this on a model that is additional fine-tuned with something that is called refusal training, this refusal state try avoid our question or avoid this harmful state, but in fact, after some, for example, jailbreaking, we still receive this harmful state. And what they suggest is, or create, and during this paper, is circuit breaker. So when model try to achieve this harmful state, they redirect the whole model to some circuit breaker, so they stop the whole model or stop the prompt. So model try to answer, but it's interrupt. And it looks like this is a very good approach for a couple of reasons. Because, for example, based on the tests, they reduce harmful response like 87 or 90% based on quite good model like Mistral or Llama. There is no impact on the whole model capability. And what is also important, because they go inside of model, they catch this harmful state. So there is not something that we need to catch on input or output. As we show you, there's easy bypass of this approach. But if you go inside of model and just try to identify all the harmful state or the most harmful state for your business case, you can just catch this and redirect the whole prompt. And because of that, you can also catch unseen or unknown attacks. And also based on what they're saying on Twitter, this is quite good for cost perspective. And this is some of those results. As you can see, there is a very good results, like the 90%. And we all wait for more information because, as I mentioned, quite new things. They mentioned that they will release the model that they use in their research. So we wait for it. Again, quite new thing. We see great potential there. This is our expression when we saw that, to be honest. So yeah, finger crossed. Some takeaways. Jailbreaking are more and more popular. Currently, we see more this kind of attack more as research approach. We don't see many real case situations, but because we know or we predict there will be more production implementation on LLMs, we can see more and more real case scenario, and based on nature of elements, this attack could be hard to protect. Perhaps this circuit breaker will be a solution. Another takeaway, open source models like Llama are getting better, and based on techniques that, as an example, Andrzej showed you this kill switch, the threat actors can use this model, they can remove whole alignment, and can use, because of that, they could use a model for their malicious purpose. So perhaps we will see more and more good phishing created by LLMs and this kind of things. If you put some information to LLM by fine-tuning or by RAG, you need to think like everybody that have access to this model, if you give the access to the developers, you need to remember that they will have access to the whole data. You can put some safeguard, but still, by some kind of jailbreaking, they can achieve the data that you think that they should not see. And because of that, classification of the data is even more important. If you have very confidential information that is crucial for your business, perhaps this is not the best moment to put this to LLM. Other good practice, like or security foundation approach, like access management, patching server that when you have the models and so on, it's still important elements, especially for things like stealing or defense model stealing. I know there is lots of new feature here, and we want to focus just on them, but all things are still important. And Andrzej mentioned about multi-models, multi-agent prediction, that we will have more and more this kind of system. And try imagine a situation that we have a bunch of agents. One of this agent takes some information from the web, and we have perhaps indirect prompt injection attack. This agent send this information to another agent, and then to another one, and cascades. And on the end, we have an agent that run a code. So it could be very hard to, in this kind of chain of agent, catch the malicious things or attacks itself. So it could be a changing element for us. And yeah, changing times are ahead. But we need to do our job. We need to catch the threats that we have, catch the risk, highlight perhaps this to the business, to give them awareness, to give them option to have an informed decision. And this is all things that I want to show you. Thanks for staying with us.